I'm Anca, and this is the place to be to hear about the latest tech trends in healthcare. For all the science and tech enthusiasts out there, this episode is one you won't want to miss. It's always fascinating to take a step back and trace the history of groundbreaking technologies, to understand not only where they started, but also where they might be headed. Today, we're diving into the incredible evolution of artificial intelligence in healthcare. From its early beginnings to the revolutionary advances we're witnessing today, AI has come a very long way. We'll explore the three major eras of AI 1.0, 2.0, and 3.0, each with its own unique capabilities, risks, and transformative potential. Welcome into the Meta Health. AI 1.0, Symbolic AI, and probabilistic models. Let's start with the roots of AI 1.0. Imagine the 1950s and 1960s, a time when researchers believed that intelligence could be programmed into machines using rules and logic. This was the era of symbolic AI. Symbolic AI worked like an intricate maze of if-then rules. Imagine a doctor's decision tree. If the patient has a fever and cough, then consider a respiratory infection. These systems could mimic human reasoning, but only to an extent. That's the case of IBM's Deep Blue, a famous example of symbolic AI that made headlines by defeating the chess world champion in 1997. While it wasn't solving healthcare problems, Deep Blue demonstrated how symbolic AI could excel in a structured domain with clear rules like chess. In healthcare, symbolic AI systems like Internist One aim to assist doctors in diagnosing complex diseases. But there were significant drawbacks. These systems were only as good as the rules written by humans, and they often crumbled when faced with real-world variability. Imagine relying on a map that cannot update itself when a new road is built. That was symbolic AI. Probabilistic models emerged as a solution to address the rigidity of symbolic AI. Rather than relying on a fixed set of rules, these models use statistical methods to analyze patterns in data and make predictions based on probabilities. For example, they could estimate the likelihood of a disease based on a combination of symptoms, offering a more flexible and data-driven approach to decision-making. While promising, they were limited in their ability to handle complex, unstructured information like medical images or free text notes. This marked the beginning of AI's pivot toward a more data-driven future. AI 2.0, the era of deep learning. Fast forward to the early 2010s. This is when AI 2.0 took center stage with the rise of deep learning. Unlike AI 1.0, deep learning didn't require programmers to write all the rules. Instead, it relied on neural networks, systems that could learn patterns directly from data. Here's an example. Imagine teaching a child to recognize a cat. Instead of explaining every detail, cats have whiskers, pointy ears, and fur, you show them hundreds of pictures of cats. Over time, the child learns to identify cats on their own. That's deep learning in action. This era brought major breakthroughs in healthcare. Deep learning enabled AI to classify medical images with remarkable accuracy. Studies showed that algorithms could detect diabetic retinopathy in eye scans as effectively as ophthalmologists. Similar advancements were made in breast cancer screening, lung cancer detection, and even predictions based on electronic health records. However, AI 2.0 wasn't perfect. These systems were task-specific, great at doing one thing but unable to adapt to new tasks without retraining. They also struggled with out-of-distribution data. For instance, an AI trained on clear, high-quality X-rays might fail when given blurry or unusual images. Bias was another major concern. If the training data wasn't inclusive, the AI's decisions could inadvertently favor one group over the others. Regulators like the FDA stepped in, creating frameworks to evaluate and approve AI tools for medical use. AI 3.0, Foundation Models, and Generative AI. Now let's talk about the present and the future, AI 3.0. This era is defined by foundation models and generative AI, technologies that are transforming not just healthcare, but the way we interact with machines altogether. But what makes AI 3.0 so revolutionary? Two things. First, these models aren't task-specific. They can handle multiple tasks without retraining. Second, they can generate content like text, images, and even code. Imagine asking an AI to write a medical report for a specialist and then rewriting it for a patient's family. The AI adapts instantly. Large language models like OpenAI's GPT series or Google's MedPalm exemplify this shift. MedPalm, for instance, has reached expert-level performance on medical licensing exams and can generate long-form answers to health questions. In tests, doctors often even preferred its responses over those written by human colleagues. But how do these models work? Think of them as prediction engines. They're trained on massive datasets, learning to predict the next word, image, or sound in a sequence. This ability underpins their versatility, but also introduces risks. For instance, they might generate plausible sounding but incorrect information, a phenomenon now known as hallucination. Bias and equity concerns remain, as does the challenge of balancing transparency with data privacy. But the potential is enormous. Foundation models could revolutionize tasks like documentation, medical education, even patient interaction. We are headed towards a future where an AI assistant will help reduce a doctor's administrative workload, hopefully allowing them to spend more time with patients. So as we've seen, AI's journey from symbolic logic to generative marvels is nothing short of extraordinary. Each era has brought unique advancements and challenges. AI 1.0 laid the groundwork. AI 2.0 harnessed the power of data. And AI 3.0 is opening the door to a world of unprecedented possibilities. That's it for today. As always, I will see you soon for another tech adventure in healthcare.